them out?
I'm hurt, sir. I'm very much hurt.
Okay. Then I'm 90% sure nobody else has checked them out. Very bad.
अफान अपने से मारा.
Okay. Now let's start. He at least studies Abu Bakr. That's something you should also do. That's
हम
not
तो
bad.
करते हैं कभी-कभी.
Okay. Now, so in this sort of question, it says a student investigates blah blah blah. I don't even sometimes read this. What I do is I straight up go to this part. All right, I'm going to go back at that. So it says that basically the experiment is repeated for different values of f. There are basically frequencies of some microphone signal generator, which is causing, the oscillation on the screen or something like that from signal generator. There's a rod and there's oscilloscope. But they have given this equation. So this is I'm more interested in. It says that basically the real question every time starts from this point, but you can actually read this sometime. That is important as well. Most of the time it's not. Anyway, so it says that a graph is plotted of d on y-axis, right? So this is important, and 1 upon x, 1 upon f on x-axis. So this is something you guys need to look for. Now, if you remember paper 3, we used to compare equations like these with y equals to mx plus c. We're going to do the same, right? So before that, I want to make sure that I have d on the as the subject, because every time you have to put something on the y-axis, that must be made subject, right? So I'm going to multiply 4 in this, so it will be 4 upon f equals to 4d plus 4k. Then I'm going to take 4k on the other side, so 4d will be equal to v upon f minus 4k, like that. Is it clear, everyone? Then I'm going to divide 4 on both of the equations. So this will be v upon 4 times 1 upon f minus 4k over 4. So this will give me v upon 4 times 1 upon f minus k. Do you guys get it?
Yes, sir.
If you have any questions here, let me know, okay? Now what you do next is you're going to compare this equation with y equals to mx plus c. You notice that on D, we have y-axis on D, we have 1 upon f on x-axis, which means the gradient will be v divided by 4 and the y-intercept is going to be minus k. Any questions here, please let me know.
No.
Please check this out. If you have this paper downloaded, open, you're very smart, then please write this down as well. Okay. Okay, Samir, now I looked at your message. It's quite funny. All right. Never. Anyway, never mind. Let's go forward. So once you've done that, this is 1 mark. You don't have to do anything. We just now need to go through this. Now in this one, it says you need to record values of 1 upon f 10 raised to minus 3 and d in the table. Now I don't know what d is, so I'm going to go back and we'll see what d is. It says a microphone is then moved until maximum amplitude is observed on the screen. A second value d2 is measured and the average value of d is calculated, which means I have to find average value of d. So that's simple. Now this value is already given in 10 raised to a minus 3, as you can see. Huh? Why मेरी क्लास में नहीं ले रही तुम्हारी क्लास? कल भी नहीं थी, परसों भी नहीं थी, आज उसकी क्लास होनी है दोबारा से. All right. So then it's going to be 1 upon f. So when you do 1 upon f, automatically this is going to change into minus 3. So you don't have to convert 1.5 into 10 raised to minus 3. You can directly divide like this. So what you're going to do is just use the calculator. Let me show you. So you just need to do 1 divided by 1.5. This is going to be 0.67. Now I want to tell you that because this is in 2 significant figures, then this answer should also be in 2 significant figures. You have to follow the same practical rules that you've learned in P3. Okay. All right. So do not get confused by how I've written this. and then keep on doing this. 1 divided by 2.1, that's 0.48. Then 2.8, that's going to be 0.36. Then you can do 4.1 again, 0.24. Then you got to do 5.2, 0.19, and then you got to do 7.6. That's 0.13. If you have any questions, please let me know here.
No.
Good. Now what you're going to do is you got to basically find the average of D values. So we'll do that now. 24.9 plus 24.5 divided by 2. That's going to be, divided by 2. This is going to be 24.7. So just write it here. I think this will be 17.4. I can basically see that. I think that's going to be 12.6, है ना? नहीं, 12.65.
12.7.
Sorry?
12.7.
12.7. This is going to be, I think, 4? 8.4, I think, है ना? Can you check?
Yes, 8.4.
And this is going to be, the middle value of this is going to be, I think, 6.7? I don't know. Oh, my bad. My math is so bad.
6.6.
Wait, 6.6. Yeah. And this is going to be 4.6 as well, probably. Just keep on dividing, it will be like this. Do you guys understand this? Any questions up till now? So ideally, by finding these values, you should not take more than just a minute. It's very quick and simple. But then the real thing is they say include the absolute uncertainty in D. This is what you want to do. Now, how do we find uncertainty? If you have two values like these, the formula for uncertainty is you do max value minus the minimum value. This is all AS things divided by 2. So what you're going to do is you're going to subtract these values and then you're going to divide by 2. So let's do that. 24.9 minus 24.5 and divide by 2 is going to give me 0.2. So plus minus 0.2. Get it, everyone? In this one, it will also be the same. In this one, it will also be, I don't know if it's same or not. Let me check. 13 minus 12.4 and divide by 2, 0.3. This one is also 0.3. You can check from the calculator as well. Okay. This one, I think it's 0.4. And this one is 0.4 as well. Can you please confirm, everyone?
Yes, sir.
Yeah, so this is going to take you about another minute. So ideally, you should be spending 2 to 3 minutes on this table. Although this table holds the most marks in every part, like it's 4 marks total. So you should basically do that as soon as possible. All right. If you have any questions now, let me know. Otherwise, I'm going to go forward.
No, thank you, sir.
Now, I like this question a lot, generally. Yes, Ryan, it's paper. I like this question a lot, generally, because the most hated thing that I have found in my students, and when I was doing my A levels as well, was when I had to draw a graph without these scales drawn. So I had to, take scales and think about that. The good thing about this is now you don't need to do that anymore. They will give you these scales automatically. All right, so you don't have, you just need to plot them. But keeping in mind, we need to have the certain rules that we need to remember. For example, it says you got to plot D against 1 upon F, and you have to include the error bars, which we're going to go next. But for now, we're going to do this. So I want you guys to help me with telling me the value of F against D, please. That would greatly, save some time. So the first value, 0.67 and 24.7, right? 0.67 would be This is 0.65. This will be 0.67 and 24.7, है ना?
Yes.
So this one is basically 25. This is basically 25. So it means this is 24.2, 24.468. So it means this point will be 24.7, right? So we got to go to, actually you will have full size paper. Unfortunately, I don't have that. Liberty. But I'll try to do it as fast as possible. I think it's here. 3 boxes onto this side, 3 boxes, so it should be right here. Now what I do mostly is I put a dot and a circle around it, but you guys need to remember that the dot should be smaller than half the box. Like if you draw a dot thicker than this size, it is going to basically be a blob, and blobs are not allowed, just like the same rules as P3. So your dot should be smaller, or if you see a point, you can put a cross, and cross should not be thick, like you don't have to, color it. Circle coloring class, that would give you no mark then. All right, so plotting should be done like that. Wait a second, please. So I'm writing it. You guys also please follow along. Wait a second. Eh? All right. Now, then the next point is 0.48 and 17.4. So let me find it. 0.45 is this one. 0.48 is this one. And the next one was 17.4. 17.4, this is 17. 17.2, 17.4. So we got to go here, right? So it means I think it should be right here. Okay, so it should be right here. I'm gonna put a circle. Is it clear, everyone? I hope.
Yes.
Yes.
Okay. The next would be 0.36 and 12.7. 0.36 is going to be this one, and 12.7 is gonna go. This is 12.5, 12.6. Sorry, 12 point, that's 13.
I think you
Sorry,
got
my
it.
bad. 12.2, 12.4, 12.6, 12.5 will be somewhere here. Was it 12.7? 12.7. Oh my god. Wait a second. That's not fair. 12.2, 12.4, 12.6, 12.8. So this will be right here. Well, that's interesting. So let's put a circle around that. Right here. Okay, so this is our point. Then the next one was 0.24 and 8.4. So 0.24 will be right here. 8.4, now it will be easy for me. 8.2, 8.4. So it's right here. Then it says 0.19 and 6.6. 0.19 is here, and 6.6 will be 6.246 right here. Okay. Then I have the next one, which is 0.13 and 4.6. 0.13 and 4.6. 4.2, 4.4, 4.6 right here. Do you guys get it? Like that. So now that we've plotted everything, we're good to go. So first of all, in the plotting, number one, plot all points. This is my advice to you. That would give you, and obviously no blobs. So this will give you 1 mark like that. Then you need to draw the error bars. Now you need to see what we have uncertainties in D, and D is basically on the vertical axis, which means error bars will also be vertical. Let me show you one, how it's drawn. So in the first one, we have basically the error of 0.2 plus minus, right? So what you're going to do is you're going to go to the point, which was the first point right here. Now you see each box has 0.2 centimeter length. So to draw the error bar, we are gonna basically, let's make it a bit smaller. We're gonna go upwards because it was in half, so I'm gonna go half, and then I'm gonna go half below as well. Do you guys get it? This is how the error bars are drawn. So on the vertical axis, because the error is vertical, so basically 0.2 upwards and 0.2 downwards. Anyone who could not understand this point, please let me know.
Won't the error
Means
bar
that if
obscure
you
the
repeat,
actual dot?
Come again, please.
Won't the error bar obscure the actual dot?
Yeah, the actual dot is in the middle, right? It's right in the middle.
But yes, but won't the error bar obscure it?
No, it doesn't matter. You can go up and down. It's okay.
All right.
yeah, can you please repeat?
Come again, please.
Can you please repeat, sir?
Yes. So this is our point, right? We got to go one box up because the error is plus minus 0.2. It means greater than 0.2. So I'm going to go two, like one box up and one box down, Dania. Do you get it? This shows that it has plus 0.2 error in this. Also, it has minus 0.2 error. This is what we're showing on this. Get it?
Yes. Thank you, sir.
Now the next one had the same kind of error, that was 0.2. So we're going to go. We also need one box. Because this one is actually at the same point, as you can see, it is exactly at a particular line. So one box up, one box down. So this should be the error bar. Sometimes the error bars are bigger as well in the question, so it doesn't really matter, all right? Drawing this. Then the next one was 0.2 as well. So I'm going to go here. So 0.2 means one box up, one box down. So because box is in the middle, so half box and half I'm doing like that, right? Then the next one was 0.3. The next two are 0.3. 0.3 is 1.5 box. What I'm going to do is one box and a half. One box and a half. Do you guys get it? Like that.
Yes.
Next one, one box and a half. One box and a half. So these are error bars. And the last one was 0.4, I remember. Let me quickly recheck it. Yes, zero. The next two are 0.4. Oh my god. I think I made a mistake. First two were 0.2. The next one was 0.3. My bad. Sorry. 0.3 means I have to go 1.5 box. So half and one, half and one. So this should be like that. This is correct. This is 0.4 by the way. 0.4 means two boxes. So it means you got to go one and two boxes down, one and two boxes down. All right. Like that. Similarly, 1, 2, 1, 2. Is it clear, everyone? So now we're done.
Yes.
Please have a look. Let me know if you have a question.
No, sir.
No question right now, sir.
Good. Now, the next part we're done with these, and then it says draw a straight line of best fit in worst acceptable line. Now, what is that? So let me just tell you. So best fit line, I want to tell you this very important point. Best fit has two conditions that needs to be met. First condition is that equal points above. Oh my god! Wait a second. Equal points above and below the line. So this is the first condition of best fit. The next condition of best fit is that line close to all points. So these are the two conditions. Now, if somebody tells you ever that it is a line that basically crosses or matches most of the points, or most of the points are above or on this line, they're absolutely wrong. Please do not listen to them. These are the only two rules that you've got to follow. If there are points coming on the line and they're meeting these two conditions as well, then it's good enough. But if there are none of the points on the line, but they're meeting, they basically, the line is adhering to these two conditions, makes correct. Now, what is worst acceptable? Worst acceptable means that you've got to go from the highest error bar to lowest error bar. So generally it is done like that, right? So I'm going to explain what highest error bar to lowest error bar means. So first, let's draw the line of best fit. Now I have a digital pen, and sometimes it just doesn't snap correctly. So excuse me for that. So right now this is absolutely wrong. Okay. Now as you can see, like I have this line. If you look at this line, you'll see that just above this point, this line basically goes through most of the points. But the thing is, there is 1 point above the line clearly, and there's 1 point below the line, right? Is it clear, everyone? Rest of the points are almost on the line. It's fine. So this can be categorized as a best fit. Now, when you do this, the examiner tells you to basically write it down as well, that this is the best fit line. Is it clear, everyone?
Yes.
Sir, what if the points are above the line?
If 2 points are above the line and none of them are below, then it's a wrong line. You have to redraw that. Okay. So this
And we have to redraw it with pencil or with pen?
This you can do it with the pencil, obviously, because you need to correct it as well if it goes wrong.
All right.
You have to use the pen. And using pen in this would be a terrible idea, actually. Okay. All right, kids. So then, you good? Should I go forward now?
Yes.
All right. So then you're gonna go to the error bar. Now, what is error bar? Worst acceptable line. So I'm gonna change the color so you have a better idea. So I'm gonna basically start off with a line from the top of error bar, and then I gotta end up at the bottom of error bar like this. Okay. And the other condition is that it should basically go through all the error bars. There should not be any line that doesn't, there should not be any point that doesn't touch the error bar. Do you get it? Like that. Okay, it's not letting me snap. Wait, it should start from here. Okay, now it's letting me snap. Oh, please, let me do it. Uh-oh. It goes crazy, sometimes. Oh my God. Okay, please excuse me for that. I will have a little bit error because my software doesn't let me do it very accurately. Anyway, I've tried my best. You see, it starts from this point, which is the bottom. It is crossing through all the error bars, and also it is meeting to the top. Actually, it would have gone through this point if my basically pen would have let me snap to this point. So if you move it closer, it will come to that point as well. Do you guys get it? So I will have a little bit error because of the snapping issue. You won't have that issue because you can place the ruler like that. Is it clear, everyone?
Yes.
Okay. So just consider this now. Anyway, so this would be should be labeled as worst fit line as well, because they expect you to do that, and they would have to write here as well. So also, just for your reminder, just write that it must pass through all bars. It should not leave any bar like that. Okay. Now, if you like if somebody thinks, okay, why can't I go from the bottom to bottom? I would say you can also do that. It's not a big deal. You can go from like this to this. I mean, this to this like this, but it's fine. So either you make a steepest possible line or shallowest possible line. It's fine. Either way, it's fine. Right? It's up to you. It's your judgment, whatever you like. All right. but it should make a crossing, it should make a crossing. Some people just draw top to top, and that's wrong because it doesn't make that cross line. Get it?
Yes.
Okay, so once you've done that, then they would say determine the gradient and line of best fit, and also the absolute uncertainty should be written. So it's okay. So first of all, we're gonna find the gradient of both lines. I'm gonna tell you why we need that, but it's very important. So let's do. So gradient rule is that when you pick a line, your line should basically the gradient point should be far enough so that at least 50% away from each other on the line. So this is my first point. I'm going to write this point. I'm going to put dotted lines here because I want the examiner to know that okay, I'm a good person and I'm helping you get this. So my this point. So I'm going to write best fit points, right? So best fit points. The first one is 0.15, and that would be 5.2. You guys agree?
Yes.
Just be careful about something. This is in centimeters and this is in 10 raised to minus 3. So it means that you also need to include that 0.15 times 10 raised to minus 3. Okay, so don't forget about that because your answer would be then different. Then take another point far away on the red line. I think any point that you like. I think I like this one a lot. So I'm going to go down. So difficult to read. Okay, so this probably is 0.66, I guess. 0.66 times 10 raised to minus 3. And the other point on this one is right here, which is 24, right? So make sure you mark it with dotted lines. So draw the triangles properly. Okay, so 24. So I have the best fit points. Now take the points for worst fit. First point on the yellow line. Let's start with the point like, what point do I like? I'm not sure about any point here, but this could do. This could do actually. Okay, let's go down. This is 0.2. 0.2 times 10 raised to minus 3, and the other point here would be 6.8. Okay.
Sir, if I remember correctly, they said we only need to calculate the gradient for the best fit line.
No. They're right. They're right. But they also said you need to find the uncertainty in that. So you have to do this as well. Okay. I'll tell you how we can do that. Just hold on. Give me 1 second, please. And then I think I like, I like, I like, well, I think this would be a fair enough point as well. So this is 22. And that would be, yeah, it's a bit of, you have to find gradients and y-intercepts again and again. That's a bit of a problem, but it's okay. So now this point will be, I think, 0.59 times 10 raised to minus 3. And that was 22, I think. 22. Okay. So once you have these points, you can then proceed in finding the gradients of this. So for the best fit gradient, I would say gradient of best is going to be 24 minus 5.2 divided by 0.66 minus 0.15. 0.66 minus 0.15, and both of them were 10 raised to minus 3 as well. Can you please find this? Help me get it. Once you do that, then you should be doing gradient of worst as well. Yes, please.
For the best gradient, I'm getting 36862.7.
3686
2.7.
Okay. And the worst fit would be, let me check. 22 minus 6.8 divided by 0.59 minus 0.2.
That would be 38974.4.
This one, right? Everybody agrees? Any questions here? Please let me know.
No.
Okay. Now, how do we find? Now, what we're going to do is how do we find the uncertainty? So, the uncertainty in the gradient is found when you basically do gradient of worst minus the gradient of best. So let's write 38974.4 minus what you get 36862.7. What you get?
2111.6.
Okay. Now just convert this to one significant figures because that's how the uncertainty is written. So that's going to be
2000.
2000. And according to that, this should be according to the same significant figures, which is 2. All right, because all of the values are 2. So this value, please. So this is
This
going to
should
be,
be 37,000 plus minus 2,000.
yes, like that. So you have to follow the uncertainty rules here. And the uncertainty rule is that this should be one significant figure always, and this should be same decimal place with the correct significant from the data. Is it clear, everyone? Any questions? Please let me know here.
No question from my side.
All right, Huda, Ryan, Sameer, Zainab, Dania, Asha, Abia, Abu Bakr.
No, thank you, sir.
Thank you, sir.
Good. Now, yes.
I don't understand the difference between worst fit and best fit.
What is the difference between worst fit and best fit?
Yes, sir.
Zainab, best fit means if you look at the line, red line, right?
Yes.
It's basically crossing the first 3 points, right? It's there on it, and also crosses the fifth point. But if you see this point and that point is this is above the line, this is below the line. Do you get it?
Yes.
So how to draw best fit is that your point should be equally divided above and below the line. Do you get it? And it should be closer to the closer to the line as well. Is it clear?
Yes.
Like you can't say this is a best fit line because there are 3 up and 3 below, but you have to also see that the line has to be close to all points as well. Get it?
Yes.
Now, worst fit line means you're gonna basically start from the top of the error bar and you're gonna end it with the bottom of the last error bar. Do you get it?
Yes.
So this way, this will give you the steepest possible line that could have been drawn. Understood? So that's the difference.
Okay.
Everything is clear? You have any other questions?
No, sir.
Just remember, when you take gradient points, they should be at least 50% away from each other. One. And they should be marked on the graph which points you're taking. It's very important. Okay. Now, so why are we doing this? Because uh, the value of the gradient will be taken as the value of the best fit gradient. But then when you subtract these two, you're gonna get the uncertainty of it. Otherwise, you cannot get the uncertainty. Is it clear?
Yes, sir.
Good. Now, what to do, huh? Very interesting. So now let's go to the next. In the next part, it says, determine the y-intercept of the line of best fit include uncertainty. Now we have to do the same thing, right? We have to do the same thing. We have to find the y-intercept. So y equals to mx plus c is our best fit equations. First, we're going to do it for the best fit. So best fit line y-intercept, we're going to take any 2 points. You can also take the gradient points, it's fine. So let's take them. 5.2 the gradient of best fit was, I would recommend that you take the gradient, not the rounded off gradient, but this gradient. 36862.7, okay? 36862.7. X point was 0.15 times 10 raised to minus 3, and we need to find the intercept. Can you please find the intercept, please? And the same way you got to find the worst fit one.
My value for C is appearing minus 28 over 85, which is the precise value.
28 over 85 is nothing. You got to tell me in decimals.
Yes, but in order to increase accuracy of the final answer, I also mentioned in fractions. But anyways, minus 0.33.
Minus 0.33. Okay. Then you can take the worst fit, one of those points, 6.8. Gradient has to be the one we wrote earlier, 38974.4, I think, 774.4. 38974.4, and the x point was 0.2 minus 3 plus c. What you get?
Minus 0.99.
0.99. Okay. Now to find the y-intercept, y-intercept uncertainty, you got to subtract these two. So do 0.99 minus 0.33. What you get?
0.665.
0.665. Now it should be written in one significant only, so we're going to write plus minus 0.7, and this answer should be in one decimal place only. So it has to be
Minus 0.3 plus
Sorry.
minus 0.7.
0 minus 0.3 plus minus 0.7. This should be your answer. Any questions? Please let me know.
No.
No.
Okay, so the same method then applies. In usually part D, they will ask you about the appropriate units, and they will say determine values of V and K. Now this is so simple. You already know, if you go to the first part of the question, you're going to see that you have gradient as V upon 4 and intercept as minus K. So we have gradient as V over 4 and intercept as minus K. At this point, doesn't really matter. You can use the values of the previous parts, because they're saying using your answers in this. You don't have to use the actual values, okay? So now the gradient was, I think, 37,000. I don't remember. Let me check. 37,000 equals to V over 4. So V is going to be?
V is going to be 148,000.
And V certainly is, now we need to check basically what are the units of gradient, right? So gradient was taken by doing change in y over change in x. On x-axis we had centimeters. On y-axis, oh my god, that's bad. And then the next one was 10 raised to a hertz minus
Basically,
1.
it becomes centimeter hertz.
Yeah, hertz minus 1 is what? 1 upon centimeter minus 1. What's that?
That's going to be
That's
centimeter
gonna
per
be
second.
centimeters per second. It's gonna be that. It's gonna be centimeters per second. So then you're gonna write 148,000 centimeters per second. Is it clear, everyone?
So considering that they said include appropriate units and not SI base units. So will we lose a mark if we write in hertz?
Yeah, and that would be, yeah, you can do that. You can do that. You can do that. Then it says include, okay, so this one. Now y-intercept was equal to minus k. Y-intercept value is minus 0.3. So k is going to be
0.3.
Now 0.3, and the y-intercept is centimeters, so it will be centimeters. You guys get it?
Yes.
Very simple. For 3 marks, it's a bargain, right? You can basically get it if you just remember that you got to take the value from behind, and it will always be the same. And then it says experiment is repeated, and now you need to determine the
What
frequency.
about the absolute uncertainty, sir? in part D.
Also include that. Okay, that's fine. So now you guys need to understand that basically V is equal to the gradient times 4, right? Sorry, I forgot about that. So gradient uncertainty, you need to multiply it by 4. So what is that?
8,000.
8,000, right? So 4 into 2,000, 8,000. So we're going to write 8,000 centimeters per second. About this one, y-intercept is just the same uncertainty as k. So that's going to be plus minus 0.7. Do you get it?
Yes, sir.
Like that. Any questions now, anyone?
No question, sir.
Then the last part, it says the experiment is repeated. Determine the frequency that will give you the value of 30. Now we're going to take the whole equation that we had. The equation was V upon F equals to 4D plus K. Okay, let's do that. V upon F equals to 4D plus K, right? All right. So we have the values. We have V, which is 14800. We got to find F. For D value is 30.
30.
They have given, and K value is 0.3. You've already found it from there. So F is going to be
1221. Or in this case, two significant figures, 1200.
1200 hertz. Right. That's it. Now, I just want to tell you people, in this exam, there is no error. So sorry, all parts are error carried forward. So let's suppose that somebody did this part wrong, and now they're thinking, okay, what do I do? You can still do this part without getting penalized because your value is wrong there. Is it clear, everyone?
Yes, sir.
In fact, if you come out of your exam room and then somebody tells you, okay, my frequency was way too high or way too low, probably you've done something wrong. It doesn't really matter. What they are looking for is the correct substitutions, correct use of formulas. Do you guys get it? Nothing else really.
Yeah.
Now let me show you the mark scheme of this. This is why if your friend says, okay, you were so wrong, my frequency was like 1800 and I've checked with another friend, she got 1700 and you're like 1200, you're so wrong. So you're gonna say it doesn't really matter. All right. So rest of the things you can, you already know already. So this was what paper? We got to go GC guide. Oh my god. Critical error. Okay. Past paper. Yes, Dani, I couldn't understand. Sorry. Just end the class in a minute. It's 2023. Okay, March. And it was 5-2. Wait. 5-2, 5-2, 5-2. Now, if you guys see this, you realize that actually you have marks for writing the same thing, writing the correct table. Where is it? Writing the correct table, as you can see. And then they've just said 6 points plotted within half a square, like I said, do not make blobs. Error bars correctly plotted. And then they've said straight line or best fit. And you see what they have written? Points must be balanced, which means equally up and below. It doesn't mean that they should be on the line always. And then they say worst fit line, steepest chiller passes through all error bars. All error bars must be plotted, blah, blah, blah. And then you see they have told you that you need to basically determine gradient with clear substitution of data points. Distance between data points must be greater than half the length of drawn line. Do you guys understand that? The point should be 50% away. Then they say you can find the uncertainty by subtracting gradient of best fit line minus gradient of worst fit line. That's what we have done. Then y-intercept should be done with y equals to mx plus c. Expect y-intercept to be negative. Yes, we had that. And then then uncertainty would be y-intercept of best fit minus y-intercept of worst fit. So that's something. And then they've said whatever they've done, they should do this. Do you see? They're not interested in your answers. They're interested in the method. All right. Your 2 to 3 significant figures, and then same goes for here. Method. Then they've said the units should be centimeters per second, meters per second, and meter centimeter. So Afan, it means they don't accept that Hertz thing. Is it clear? Anyway, then they said you got to find the absolute uncertainty, as you can see, and then they tell you to use the correct substitution. Like I said, they are not interested in your answers. If you get something wrong or you can't understand that, just take supposed values and go forward to the next part. So you at least get the marks for the rest one. You don't need to worry about anything that, okay, my value is too big or too small, it's minus, negative, I don't know. So don't worry about that. Is it clear, everyone?
Yes, sir.
Yes.
So that would be all then. So this is paper 5.